Okay, well, we might kick off just a few minutes late. Thank you, everyone, for coming back after lunch break. I know it's beautiful weather outside with some tasty food, but I'm glad that you're back here in the room. To introduce myself, my name is Jamie Gillespie. I'm a senior security specialist at APAN, one of the founding funding organizations for the training events and meetings that are going on today. This session, we're looking at RPKI use cases and experiences, and we've got 3 virtual presenters and 1 in-person presenter. So I'm going to start off with the first virtual presenter, which is going to be Aaron Murray. He's presenting on the topic of enabling RPKI route validation on the REANS edge. So I'll hand that over to you, Aaron, if you want to start sharing your screen.
Thank you. Yes, I'll do that. Cool. Is that? Yep, that looks good there. Yes. Firstly, apologies that I couldn't be there with you in Nepal. Unfortunately, we've got a couple of hardware and optical circuit procurements going on at the moment where we're hitting some milestones on that in the next couple of weeks, so I didn't have time to get away. But anyways, let's carry on. So yeah, I'm here to talk about sort of how the experience that REANS has had enabling route origin validation on our network. So we originally started off doing this in 2019 is when we first enabled it. And actually it was a very different landscape back then and it was far less talked about. So it was quite an interesting experience. So first and foremost, REANS has peering points sort of in a few key locations in the US, in the Pacific, Australia, and obviously in New Zealand. We have peerings obviously with internet commodity providers, other NRENs, as well as NREN exchanges such as Gorex and PackWave. We've got private interconnects and we have all of our member internet connections. So we wanted to enable RPKI route origin validation on all of these peering points. So first things first, we had to do some pre-checks to see how badly we were likely to break things if we enabled this. So the first thing that we did was we enabled RPKI policy, but you'll see there in the bold, basically on an invalid, we still accepted, or at least went to the next term to eventually accept that routing policy, that route. This allowed us to actually populate our routing table with validation state enabled so that we could see what we would likely drop if we were to turn it on. So this is sort of what we saw. I actually took this dump today on one of our peering exchanges. There's a few invalids on this one. There's 13, I think. And so one of the first things we did is we dumped the routing table, did a little bit of parsing to grab the origin AS of every single route we were looking to drop, and turn that into essentially a spreadsheet with organization names. To have a look through there and see if there was anything that we were deeply concerned about. Now, I will say one of the things that we didn't, one of the big things that you'll find with invalid routes in RPKI is that it's sort of smaller routes that have a legitimate covering route that will actually still allow the traffic to work to that location. I did actually want to write some code to sort of do a little bit of analytics on that to see how much actually disappeared that didn't have a covering route. Unfortunately, when I thought about it, the code, although not terrible, was going to take me more time to implement than I wanted to spend on it. But this little thing here was pretty easy to implement, a little bit of Python parsing, and then a little bit of an API call out to Whois to take your origin AS and turn it into an organization name. So scrolling through that, we had a look through and went, there's not too much on there that we're super concerned about. So we, turned it on. So that next policy turned into a reject and we started dropping all invalid routes. Now, I then went to the RIPE tester to see if RPKI was working, and I got this happy face when the day before I'd gotten a sad face. So it all seemed to be working fine. Unfortunately, I've put the link in there, but unfortunately, it looks like they've turned the old one off while they're busy working on a new one. So actually, that link doesn't work today. So for the post checks, it basically went like this. We just sat at the phone and waited for people to call in to see if they were experiencing any issues that we hadn't foreseen. And actually, no one called for quite some weeks. I think it might have been a couple of months afterwards. We got our first call to say, hey, there's a part of the internet that we couldn't get to. And so we had to go through the process of figuring that out. Now, pretty much every time, and actually it's only happened maybe 5 or 6 times in the 4 years or 3 and a bit years since we actually turned it on. But pretty much every time the diagnostic process basically goes like this. And it's your member saying, I can't reach some service provider's network. You going, oh, well, that's because they're not sending us routes. They've obviously broken their BGP route filters. Them going, oh, but our BGP route filters are fine. We're definitely advertising the route to you. And us going, yeah, that doesn't look right. And then about an hour later going, oh, hang on, it could be RPKI. And from then, it's easy to check and enable a whitelist while they go and fix their ROAs. So what's changed from our perspective since 2019 when we first enabled route origin validation? Well, firstly, when we did in 2019, no one that we connected to actually did origin validation. So no IXs, our commodity internet service provider didn't, no one did a route origin validation. So we basically saw 5,000 invalids from the start. That's changed significantly. Most IXs we connect to have route origin validation in place now. And so that number of invalids that we actually see has dropped quite significantly. And in fact, when I was looking for those screenshots earlier, it took me a little while to actually find somewhere where route origin validation wasn't enabled and I could actually capture some invalid routes in our routing table. And so the question is, given everyone else is kind of doing ROV or exchanges and sort of tier 1, tier 2 service providers, is there any point in you doing it yourself? Yeah, there is, absolutely. You'll want all of that infrastructure anyways in order to turn it on facing your customers. So if it's already there, you might as well put it on all of your upstreams. You don't have to then rely on the upstreams doing the right thing with RPKI. If their infrastructure breaks, yours still continues to function. So definitely a lot of value in still continuing to run that yourself. And that's it from me. Thank you.
Thanks very much. Next, we are presenting.
Okay, I will share my screen for a minute. Okay. Okay. Hello, everyone. I'm Yan Li from the computer. Oh, sorry. Can you hear me?
Yes, we can.
Oh, okay, great. Okay. I'm Li, the Computer Network Information Center, Chinese Academy of Sciences. I'm very glad here to share our observations and thoughts about the ROA encoding and management. Okay. As we all know, BGP seems that I just kicked it out. Sorry.
Just lost you for a second there. We lost your screen share.
Okay, I will continue. Sorry.
Thank you.
Yeah. Okay, I will go fast. So here are 2 examples. One is for prefix hijack, and the other is for subprefix hijack. They are achieved by the attacker using a shorter route and a more specific, respectively. ROA is designed to stop these hijacks by cryptographically binding an AS with IP prefixes. This AS is always the two. I'm so sorry, it seems some internet error with my site, so I'm always kicked out. Can you hear me?
Yes, we can.
Okay. Okay, we'll continue my. Okay. ROA encoding has been standardized by the IETF, and ROA is encoded in different formats, different stages during its life cycle. In the common part, the most important component is an ROA prefix block, which is defined by an IP prefix along with the maximum length of IP prefixes the AS is authorized to use, which represents a subtree of the prefix tree. In addition, we define delta L of an ROA as the difference of the maximum length parameter and the IP prefix length of this ROA. Next, I will introduce some issues resulted by current coarse-grained management of ROAs. First, in constructing ROAs with maximum length encoding, the maximum length parameter +1 or -1 may involve a set of IP prefixes. As such, the authorization of some prefixes may also involve other prefixes that will not be originated by the AS in the routing system, leaving several holes in the encoded subtree that looks like a triangle. This may lead to the forged origin subprefix hijacks. Such an ROA is defined as a loose ROA in RFC 9319. More figuratively, we call it a holy ROA. We made some statistics about the holy ROAs. First, we tracked more than 500,000 ROAs published in 2020 and found that most of them can survive in less than 2 months. Then, on every day, we calculated the number of hosts in an ROA prefix block with the RIB connected on the same day. Then we observed the varying trend of the whole ratio of these ROAs. Clearly, the bigger the ROA address block, the higher the whole ratio on average. What's interesting, the whole ratio stays very stable and the time goes on. Just to say, in most cases, once a whole is produced, it will stay here all the time. Currently, authorization updates can only be done at the granularity of a whole ROA. However, in some cases, we may want to withdraw part of the authorizations that have been granted to some AS. The request to withdraw the exact part of authorizations will get rejected due to the operational granularity. What we can do are as follows. First, we have to find out the ROA that has ever been published and contains our authorizations we want to withdraw, and then withdraw it as a whole. In addition, we may have to construct and publish a number of smaller ROAs for those authorizations that should be kept. We call this excessive withdrawal. We collected validated ROA payloads for 2 months and calculated the difference between those of every 2 consecutive days, where we counted total withdrawals and the number of excessive withdrawals. Though the ratio of excessive withdrawals is low currently, we indeed observed a number of such withdrawals almost every day. Next, I will analyze in detail the issues resulted by coarse operational granularity in the scenario of resource allocation. Suppose the provider X allocates a sub-address block to its customer Y. In case that there is no ROA with X, the root of X cannot be protected by RPKI. Once X is issued an ROA, the situation will fall into one of the following 4 cases. In case that Y's prefix is included in the ROA of X, no matter whether Y has an ROA or not, namely case 2 and case 3, there must be prefixes that are authorized but will not be originated by X in the routing system, leading to holy ROAs. To avoid this issue, excessive withdrawals are needed. Then case 2 and case 3 turn into case 4 and case 5 respectively. On the other hand, in case there is no ROA with the customer, these routes will be identified as invalid due to the ROA with the ROA of its provider, leading to reachability issue. We connected 14 RIBs on the first day of every month of last 14 months. For each RIB, we focused on those root pairs where the prefix of one root covers the prefix of the other one, and they are originated from different ASs. Then with VRPs connected on the same day, we classified those root pairs into 5 cases mentioned in the last slide. In IPv4, such root pairs involved around 20% of the routing entries in one RIB. Among these root pairs, 7.6 to 10.5% are in case 5, where the 2 routes are associated with non-overlapping ROAs. This is the recommended configuration, while more than 33% are in case 1, where the route with a less specific prefix is unprotected. We do need to promote the deployment of RPKI to reduce the number of unprotected routes. Besides, more than 12% are in case 2 or case 3, where holy ROAs will be produced. To stay away from the forged origin subprefix hijacks, we should remind the providers to withdraw part of its authorizations if those prefixes have been allocated to their customers. And last, around 2% are in case 2 or case 4, which will lead to reachability issues. To avoid such issues, we should remind customers to make sure that they get their ROAs for their resources allocated to them. The situation in IPv6 is similar. Now I will make a brief summary of issues. First, with the max-length encoding, a set of IP prefixes have to be authorized together. This operational granularity makes security and scalability the 2 sides of one coin. If we prefer to security, we may have to issue a large number of ROAs to avoid or to reduce holy ROAs. In contrast, if we prefer to scalability, we may produce many holy ROAs, which are threatened by forged origin subprefix hijacks. Second, withdrawing authorizations and the granularity of a whole ROA indeed restricts the flexibility of ROA management. Instead of excessive withdrawals, I believe it is more friendly to network operators that they are enabled to directly withdraw the exact authorizations they really want to withdraw. Regarding the IP resource allocation, to avoid reachability issues, we strongly recommend to issue the customer an ROA for the resource allocated to it. Then, in case that the provider's ROA intersects with the customer's ROA, the provider's ROA becomes a holy ROA. To address this, we recommend the provider to withdraw the overlapping authorizations, which requires to make excessive withdrawals currently. In a word, holy ROA and excessive withdrawals are the 2 fundamental issues with current coarse-grained ROA management. To address them, the ROA encoding should enable authorization management and a fine granularity of an IP prefix. Now I will present our solution with a novel bitmap encoding scheme. We call it the Honing ROA. Instead of using the max-length parameter to encode an ROA prefix block, the HROA encodes an ROA prefix block with a bitmap. In such a bitmap, every bit except bit 0 represents an identical prefix in the ROA prefix block. And a set bit indicates that the prefix corresponding to this bit is authorized. In this way, authorizations can be managed and the granularity of a prefix. Besides, the bitmap can be updated as a whole with bitwise authorizations, enabling coarse-grained operations as well. This is just the very basic idea of HROA. More details can be found in our paper. To evaluate the encoding efficiency of HROA, we collected VRPs and the RIB on the same day and constructed 2 sets of authorized prefixes. First, all the prefixes in the RIB that are contained in the VRP make up a dataset, which represents the current status, while all the prefixes in the RIB can form a dataset representing the future, where all routes are protected by RPKI. 2 other schemes are also evaluated for comparison. Max-length is the standardized encoding scheme. Their delta L represents the solution that is setting the delta L to 0, that the maximum length is equal to the prefix length. Obviously, HROA has a higher risk encoding efficiency. It can reduce more than a half of VRPs in comparison with the standardized solution. With RIBs of 20 years, the superiority in scalability of ROA is demonstrated clearly as well. In the end, I will summarize this talk and highlight some recommendations. With extensive statistics and analysis, I share our observations that current coast-grade ROA management may lead to security and scalability issues. To address these issues, I present the basic idea of Hanging ROA, a bitmap-based encoding scheme that enables flexible and fine-grained ROA management with high encoding efficiency. We recommend providers to issue ROAs for their customers after resource allocations, and recommend operators to take fine-grained operations in managing ROAs. That's all. Thank you.
Excellent. Thank you, Young-Go, for that wonderful presentation showing the different problems for withdrawals and hangings and pools. Next up, we have Warren presenting. Are you okay to present next, Warren?
Sorry, I've forgotten how to unmute myself. I'm sorry, it's 2020 calling again. One moment and I will present. Okay. Can you see the screen? Okay, so my name is Warwick Mitchell. I am the head of network and systems architecture at ARNet, and I am here to just talk about some lessons learned in regards to RPKI, but not only from ARNet's perspective, but as my role as the chair of Manners. So I want to just talk through a few little bits here, and I really want to highlight that there are some really key important things, and Aaron and Yanabo have talked about some of these, but I'm just going to briefly go over a couple again, just because from an operational perspective, I think they're so important. So the first thing is training is important. I cannot stress this enough. One of the things that I constantly hear about when I talk to people about what's going on with RPKI and Manners and so forth is, how do you actually see if a route is valid, invalid, or unknown if the looking glass you're connecting to doesn't show any of that information? It's really hard. So some tools that I'm going to show in a couple of slides will help you see a couple of ways you can tell whether or not you should be looking for an RPKI invalidation. But the really good question is, does your own looking glass tell you? Because you'd be surprised how many people's looking glasses won't tell you that a route is invalid, or that they don't know that they need to look for the word invalid, because this is one of the things that causes a lot of grief as people deploy RPKI, especially with route object validation. The other thing is, does your customer even know what a rower is? You ask a lot of people, and a lot of people will go, a rower? I've got no idea. What's that mean? And so one of the things that is really important is also articulating to your clients what a route object authorization is, but also why it's important for them to create it. Now, there's some things that I will talk about in a moment, but if you don't understand what a rower is and you create some rowers, you may cause your own network to go offline. Now, in some cases, if the customer is multi-connected via multiple upstream providers, that may not be such an issue if they've created the right rower for at least one of their providers. But if they haven't, or if they're using different ASNs to announce the same route, that can cause a lot of grief. So one of the questions that I deal with is, I talk to our customers and I actually say, well, do you want me to help you create the rower? Do you want me to sit on a phone call and walk you through the process so that you understand what it is that you're doing? And I give them some checks that they can use to actually go and actually check whether or not the what they're going to deploy is actually going to make sense. Now, some regional internet routing operators or RIIs actually have a really useful tool that actually says, this is what we see in the internet. If you're going to create a rower, you should create these rowers, because then you're covered for what you're announcing today that we can see. versus someone just creates a /16 rower, but doesn't realize they're announcing /24s. And therefore nothing actually happens, nothing works for them because in essence, it's just all over Red Rover. So with that, it's important to make sure that you actually sit down and talk to them and make sure that they understand what it is they're doing from not only the rower side, but also if there is an IRR route set, making sure that they match, because if they don't match, you're also going to cause routing problems. And this becomes a really big issue for a lot of customers. The other part is, does your customer use a DDoS scrubber? If they do, are you actually making sure that that customer's created an appropriate rower for the DDoS scrubber? Otherwise, the DDoS scrubber goes to announce the route to the world. It's not being accepted by everybody. It's being partially accepted. So you get this really weird mixed match of actually some data's scrubbed, some data's not. Why is it coming in this way? What's going on? This is really important. So that's why I just wanted to highlight those. The other thing that you need to be aware of is, what is your RIR provider? So I'll use Appnix as an example, but what is their policy if you don't pay your bill? Are they going to change the rower ASN to a different ASN number, meaning that your rower is now basically blacklisting your IP space on the internet? There have been situations where that has occurred, and there are questions that are being asked of the regional internet routing registers to actually make sure that there's a clear policy on how and when they do these sorts of things. Now, just to be clear, that wasn't Appnix, the example I was just using. I just want to clear that up. But there are others that have been out there and done that. So one of the things that I wanted to show you is some useful tools. Now, some of these you can install yourself, but these are the two predominant tools that I use when I want to try and figure something out. Now, there is a couple of reasons why I use these two different tools. One, because I'm trying to promote manners on the left-hand side. And on the right-hand side, I also want to look at real-time data. And so in this particular case, you can see on the left-hand side, we've got the manners rower stats tool. You can put your ASN in there and you can see the number of valid routes, unknown routes, or invalid routes for your ASN. This is really useful when you're trying to figure out how much of my network is covered and how much of my network is not covered, because a lot of us announce customer routes as our own ASN, which then creates a really interesting result when you look at it from a manners perspective of, are you actually RPKI compliant? You are, but your customers are not, if that makes sense. So there's some interesting learnings there that we're working through on the manners side. But on the right-hand side, using a tool like Routinator, and RIPE has graciously published one of their Routinators publicly on the internet, so you can go and query it. You can see here that I've gone and queried one of ARNet's /16s, and you can see here that we have a valid /16 with a max prefix length of /24 for ARNet's AS, and that's really useful because this updates within, I would say, within about 15 minutes of a rower being registered and pushing through all the various systems, which is really useful when you're trying to push a rower and you're like, is it working? Is it not working? How long do I wait? How long do I not wait? So using a tool like Routinator and knowing that it's, you can see here that it updated, oops, sorry. I'll just use the annotate feature. Well, it's not letting me do it. Sorry, let me try that again. You can see here that it updated 3 minutes ago on the RPKI status. So you can see how long ago it went to refresh all of the cached key data from all of the various routing registries. So that's really useful. And then the other part, and I mentioned this before, was the IRR data. You can see how long ago it fetched that to see whether or not these were valid or invalid. And you can see down here more specifics or what's going on. So that's really useful to actually go and check whether or not things are valid, invalid, and where they stand. So one of the things as I said, as part of my wearing my manners hat for a second, and also Arnett, was I went to Apricot, and I can't recommend Apricots enough for the hackathon. And in the hackathon, we actually sat down and we did a hackathon to just determine how many rowers are created for all of the routes that were existing. Now, this is from Daejeon in Korea. So this is a few years ago, but it just gives you an idea. And I just want to highlight here. So back then we had 1/8 with a rower on it, 1/8. But what's really interesting is you come down here and you can see a majority of the routing table. Most people were putting in entries around the /24, if you can see there. But then it got really interesting. Why are people creating /32 rowers? That seems a bit odd. Now, something that I want to just bring to people's attention, when you create these, you've still got to understand that you're taking up some of the resources within your router's capabilities. So be mindful of what you're actually creating rowers for. If you don't need to create a /32 rower, then don't. But I just looked at that and went, that's really interesting. And then what was interesting for me was, looking back over at the IPv6 one at the same time, there was, 15/56s, 247 /64s. Interesting. But what was really interesting was all of the IPv6 up the top at the larger block sizes. There were some legitimate reasons for some of these, but some of these were also research purposes. So take it with a grain of salt. It's there to help you, but at the same time, there are people who are deliberately putting things in just to see what breaks for them and doing tests and so forth. So that's my brief little spiel on lessons learned and historical tools and examples. But I hope you found that useful, and I would be more than happy to talk further if people wanted me to do so. But if there's any questions, please let me know. Thank you.
Thanks.
Can everyone online see the slideshow? Assume you can. So my name's Christopher Bruton. I'm from Scenic, California, and I'm here to talk about our own RPKI journey, which is very new. We're not very far along in the process, but I'm going to share what we've done so far and what next. So just if you're not familiar with Scenic, we're California's regional research and education network. We have charter associates like our community colleges, the Cal State University system, UC system, and private universities like Stanford, Caltech, USC, as well as libraries and Naval Postgraduate School. This is just an overview of our network. We run our own optical fiber over the entire state, and around 20 million Californians use Scenic one way or another. If you include K-12 schools, universities, colleges, libraries. So we cover a lot of ground. We only have about 100 employees or so. So sometimes things are a bit slow or challenging to get started on. I borrowed this slide from APNIC's training. I think most of you probably already know why we do route origin validation. So I'm not going to go too closely into this, but I just wanted to highlight the different components here. We have our global RPKI repositories, which are run by regional internet registries like ARN, APNIC, right, and so on, as well as delegated repositories. And then the validator is software that we run locally that our routers can then reach out to download ROAs and their valid status. So I think I have Okay, RPKI architecture. So just what I was talking about. We have repositories, validators, and routers, and that's essentially the three components we need. The routers, they pull from the validator cache, which is generally accessible over a trusted local network connection. So they don't need to perform the cryptographic verification themselves. So what we've done at Scenic is we decided to use Routinator, which is an open source RPKI validator. I think Warwick just showed the public instance that right makes it, but we've installed 2 private instances of Routinator, 2 locations in Sunnyvale and in Tustin here in Los Angeles. And they're running on VMs. They don't take up very many resources. They have 4 gigs of RAM, 1 vCPU, 15 gigs of storage. And our systems team set up an Ansible role so they can be easily redeployed. If we could add more pretty easily if we wanted to. So far we started with a validation pilot project. So we chose one low impact router. We got it talking to the validators. We're not yet rejecting invalid routes on this, but we're successfully able to get the validation state appearing in the routing table, which you can see in the lower right screenshot. So what's next? So that's where we are right now, but we're kind of doing more planning and considering and engineering for what's next. So by the end of the second quarter of this year, so by the end of June, we plan to implement validation on our PNI and exchange peers. So we will begin rejecting our valid routes from our peers, at least in theory. And we have no timeline yet to validate routes from our associates, which are our customers and our members. And I'm going to talk more about that on the next slide. So I think Warwick and mainly Warwick's presentation talked a lot about this as well. We need to provide lots of support and education and resources to our associates. Like you said, what's an ROA? I mean, maybe they don't know. We have some really big associates which have strong, large networking teams. They're probably going to be fine. But then we have some very small county offices of education, some small libraries, elementary schools who maybe don't have the resources to figure this out on their own. Another big challenge, which I think is probably specific to the ARIN region, is legacy resources. So ARIN doesn't provide RPKI services to customers who have not signed a registration services agreement. And that covers many of the universities in the United States, which were some of the very first to receive gigantic IPv4 delegations in the 80s and 90s. And for one reason or another, these universities do not want to sign an RSA because it might mean they have to pay more money. They have the sense that they're losing control over the resources that they feel they own. So that's a challenge that each group, each university is kind of handling a bit differently. Kind of with their own legal teams and business reasons, they may choose to sign an RSA agreement or not. But we have no plans to drop our API unknown, just like virtually all providers. But for associates who do choose to sign ROAs, there are some various pitfalls, and the risk is they could inadvertently make their routes invalid. So I think our previous presenter talked about holy ROAs, and that's kind of what I'm talking about here as well. The best practice is to generate ROAs for the exact prefixes that we advertise. So avoid using the max length parameter. What I mean is set it to the same as the prefix. Another problem is, over the internet at large, we don't pass /24s, anything larger than the /24, anything bigger than a /48 over the internet, but within the scenic zone infrastructure and with some of our associates and peers, we actually do advertise prefixes like /32s and /29s. So we need to be very careful to generate the right ROAs with that, as to not inadvertently inject the prefixes. So some of the possibilities for automation that we're starting to think about, we're thinking about how we could go from our routing registry objects, we mainly use RAT-B right now, go from route objects, route 6 objects into ROAs in Erin. So we have not done this yet, but we're starting to think about ways we could automate this process for accuracy and convenience. So what else? So the legacy resources issue kind of affects us as well, because we have resources that technically belong to the Cal State system that they have allowed us to use, but they are covered under, they're like considered legacy resources. So so that's something that's affecting us, as well as prefixes that they're covered by an RSA, but they don't formally belong to scenic. So we're not able to access RPKI services for that. And then, of course, we delegate some of our address space to our associates. So just an example here is we have this /32, but then we assign some /48s to various of our associates within that /32 space. So, if we created an ROA for that /32, then these /48s advertised by different ASNs would be valid unless they also have ROAs. And then kind of this is my last slide, the cryptographic considerations. So we're still trying to decide what validity period. So do we assign these for 2 years, 5 years, 10 years? I've seen different sources that say different things about the best validity period. How do we handle renewals? Currently, Erin doesn't offer hosted private key services, so they're not able to automatically renew these for us. So that could potentially change. I think there's some proposals to start offering that, but then we give up some of the security because then our private key would end up being hosted by Erin instead of kept in your custody. But for now, we're still trying to consider how do we keep our private key secure, who has access to it, what to do with it. It's compromised. So yes, thank you. It's my contact info if you have questions later.